let's talk about the graphs of exponentials and shift them around a bit. And to add to our toolkit set of functions, we're going to add y is equal to b to the x. And it's going to look like one of two things. If b is greater than 1, then we're going to have our toolkit functions start like this, increasing as we move from left to right. It'll go through 0, 1. And if our b is in between 0 and 1, then it's going to be a decreasing as we move from left to right. It's still going to go through 0, 1. We'll see that y equals 0 is a horizontal asymptote for that. To start with, the domain is all real numbers, so you can plug in anything. And its range is going to be open 0 off to infinity. It never actually touches the x-axis, so we do not get to include the 0, but we do get everything above that. So those are the two thoughts we're going to start with. So let's start graphing the following. Okay, so let's start with f of x is equal to 3 to the x plus 4. The toolkit function that I'm going to start with is a 3 to the x. 3 is bigger than 1, so it's going to look more like that one on the left. So here is 3 to the x, and it's going to go through 0, 1 to start. Now that plus 4 is outside of the function, so I'm affecting y values. So it's going to do exactly what you think it's going to do. It's going to move this point up 4. So 1, 2, 3, 4 up here. It's now at 0, 5 because I added 4 to the y value. And previously, that horizontal asymptote had been at y is equal to 0. That's also moving up by 4. So here is y is equal to 4, and that's going to be my new horizontal asymptote that I'm going to get close to. So here's the graph that I want. It's the y is equal to 3 to the x plus 4. Its domain is still all real numbers. You can see it exists everywhere to the left, everywhere to the right if I kept drawing. But its range is only from open 4 off to infinity because we moved it up by 4. It has a horizontal asymptote, I'll go with HA for short, of y is equal to 4. All right, next one. Let's go with g of x is equal to 1/3 to the x minus 2. 1/3 to the x is the toolkit function I'm starting with. 1/3 is less than 1. So give or take, here is y is equal to 1/3 to the x, and it goes through 0, 1. It has a horizontal asymptote of y is equal to 0. That minus 2 is outside the function, so I'm going to move everything down by 2. So my horizontal asymptote is moving down to y is equal to -2 because it was at 2, 4. And the point 0, 1 is also moving down by 2, so now it's at 0, -1 because I subtracted 2 from that y value. Drawing the rest of it. So there is my g of x is 1/3 to the x minus 2. Oops, that minus is a little high. Let's drop it down. Minus 2. Its domain is still all real numbers because it exists everywhere to the left, everywhere to the right. Its range, you can see, is open to -2 off to infinity. It does not exist below -2, but it does exist everywhere above it, and its horizontal asymptote is at y is equal to -2. All right, moving on to the next ones. We got a lot to go through. So 4 to the x plus 1. My toolkit function that I'm going to start with is just 4 to the x. 4 is bigger than 1, so give or take, I'm starting with an increasing function. That goes through 0, 1, has a horizontal asymptote of y is equal to 0. Now that plus 1 in f of x is equal to 4 to the x plus 1 is inside the function, so it's going to affect my x's. So it's going to do the exact opposite. You'd think you'd move it to the right one, but it's going to move it to the left by 1. So if I move this 0, 1 to the left by 1, I am now sitting at -1, 1. My horizontal asymptote is still y is equal to 0 because I didn't move up or down at all. It'll just take a little longer to get closer to it. So it looks something like this, but it will still get really, really close to that x-axis. Its domain is still all real numbers. It exists everywhere to the left, everywhere to the right. Its range is still open 0 off to infinity. Does not exist below the x-axis, never touches the x-axis, but it does exist everywhere above it, and its horizontal asymptote is still y is equal to 0. Next one, 2/3 raised to the x minus 5. 2/3 is less than 1, so toolkit function I'm starting with, give or take, looks a little like this. Goes through 0, 1, and this guy was just 2/3 to the x. The minus 5 is inside that function, so it's going to affect my x's. And it's going to go to the right by 5 because they do the exact opposite of what you think. So 0, 1 is going to go to the right by 5. Bless me. So it's now over at 5, 1. Horizontal asymptote is still the same. It didn't go up or down. I'm just going to sneak down here. I'll be up there, something like that. So here's my y is equal to 2/3 to the x minus 5. Domain, still all real numbers. X is to the left, x is to the right. Its range is still open 0 off to infinity because I didn't move that horizontal asymptote up or down. So I still have a horizontal asymptote at y is equal to 0. Okay, how about, let's see, 4 times 2 to the x. So 2 to the x is the toolkit function I'm starting with. 2 is bigger than 1, so give or take, I'm starting here. Goes through the point 0, 1. And now I multiplied by 4. I multiplied by 4 on the outside, so I'm going to multiply all my y values by 4. So 0, 1 is now going to be 0, 4 because 4 times 1 is 4. My horizontal asymptote isn't moving though, because currently my horizontal asymptote is y is equal to 0. 0 times 4 is still 0. So it's just going to be 4 times away as it is from the x-axis. So for example, this distance right here is now 4 times that total distance. Okay? So my domain, still all real numbers. X is everywhere to the left, everywhere to the right. The range is still open 0 off to infinity. It still has a horizontal asymptote of y is equal to 0. We just stretched it vertically. Okay, how about this one? -2 to the x plus 3. So I'm going to start with 2 to the x because that feels like the base or the toolkit part of that. 2 is bigger than 1, so give or take it looks a little like that, and it goes through 0, 1. It's multiplied by -1 on the outside of that function. So I'm going to do the multiplication first because multiplication comes before addition or subtraction. It's negative outside, so it's going to flip it down. So I'm going to reflect it across the x-axis. So here is -2 raised to the x. Now the exponent goes first, keep in mind, so that notation is the same as if I put parentheses around the 2 to the x. I multiplied every single y value by -1. So that point is now 0, -1, but I still have a horizontal asymptote of y is equal to 0 because 0 times -1 is still 0. But now I have a plus 3. That plus 3 is inside this function. So that plus 3 is going to affect the x's, and it's going to move it to the left by 3. So 0, -1 is going to come over 3, right about there. So -3, -1 is a point on that graph. I didn't move up or down, so I'm still going to have that horizontal asymptote of y is equal to 0, but here's the end result. Y is equal to -2 to the x plus 3. Domain is still all real numbers. You can go anywhere left, anywhere right. Range, though, is pretty interesting this time. Looks like I can go all the way down, so it's all the way down to -infinity, but I only can come up to y is equal to 0. So I still have that horizontal asymptote of y is equal to 0 also. So that's some examples of graphing exponential functions with shifts and stretches and translations.